Hello students, this video lecture will cover section 12.3, inscribed angles. Our learning goal for this lesson will be to find the measure of an inscribed angle and to find the measure of an angle formed by a tangent or a chord. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. An arc with endpoints on the sides of an inscribed angle and its other points in the interior of the angle is called an intercepted arc. The inscribed angle theorem states that the measure of an inscribed angle is half the measure of its intercepted arc. So we get the formula that the measure of angle B equals 1/2 the measure of arc AC. So here we have two problems that use the inscribed angles theorem. We're asked to find the measures of angles A, B, C, and D. And so in this left-hand question, we have an intercepted arc that, since this chord goes through the diameter of the circle, we know that this arc over here must be 180 degrees. So because of that, we have the measure of angle A as half of 180, and half of 180 is in fact 90 degrees. So this triangle is actually a right triangle. Okay, so if we look at this second example and we draw angle A into the figure, what we see is angle A cuts off arc BC and arc CD. So by the arc addition postulate, we can see that the arc from B through C to D is going to have a total angle measure of 190 degrees. So angle A is going to be half of that, or the measure of angle A is going to equal 95 degrees. And what we're going to do is we're just going to work our way around this figure. So if I draw angle B into this figure, and I'm going to do these in different colors because I think that is helpful. Angle B cuts off arc ADC. So arc ADC is one part of 64 and another part of 90. So this arc cut by this green angle is going to be 154 degrees. So the measure of angle B is going to be half of 154, or 77 degrees. Working our way around to C, drawing angle C here. We have 64 plus 106. That's a total of 170. And 170 divided by 2 gives us the measure of angle C being equal to 85 degrees. Our final angle is going to be angle D. So we'll have that in purple. And if you look, angle D cuts off an arc of 206 degrees. And so the measure of angle D is going to be half of 206, or 103 degrees. We have the measure of angle A, the measure of angle B, the measure of angle C, and the measure of angle D. So we're talking about an inscribed quadrilateral. So a good thing to do here is check the sum of these angles against what we know it should be, 360. And if we add these four angles together, we in fact find out that it does add up to 360, so we should be fairly confident in our work. Now there are three corollaries to the inscribed angles theorem. The first one states that two inscribed angles that intercept the same arc must be congruent. So you can see here, if I were to draw both angle A and angle B, they would actually cut off the same arc. They would cut off this blue arc. Because of that, those angles must be congruent. The second corollary says that an angle inscribed in a semicircle must be a right angle. So if the angle intercepts at a diameter, that angle must be right. And then the third corollary states that the opposite angles of an inscribed quadrilateral are supplementary. So if we go back one example, you'll see that the 95 and the 85 do in fact add up to 180. And angle B and angle D, also opposite angles. 77 plus 103 is 180. So here we have a few problems, and we're asked to use the corollaries to find the measure of each numbered angle. So this first angle on the left, angle number 1. The first thing that I want you to recognize in this type of situation is I want you to see that angle 1 meets a diameter. So even though we have this 40 and this 70, those are actually completely worthless in this question. The fact that this angle intercepts a diameter is our big clue, and that means that that angle is a right angle. Now the circle in the middle, we can do the exact same thing. Because angle 1 cuts off a diameter of the circle, we know that angle 1 must be a right angle. Now since angle 1 and angle 3 are opposite angles, they have to be supplementary. So angle 3 is also a right angle. The next one that we actually need to concern ourselves with is angle 4. Because if we look at angle 4, it cuts off this 60 and 80. So adding those together, we find that this is 140. And so 4 is going to be half of 140, or 4 is going to be 70 degrees. So that means that the remainder is left for 2, so 2 has to be 110 degrees. So again, this third circle gives us a piece of information that's not really worthwhile. This 70 degrees doesn't really do much for us. If you look at where the 70 is, it's not attached to an inscribed angle, it's not attached to a central angle, so those are probably fairly good clues that we're not going to use the 70. The 38, however, is in fact an inscribed angle, and you can see if I extend the 38 degree angle, it cuts off that one blue arc. Well then if I look over at 2 and I extend the green angle, you can see that they both cut off that same blue arc. Because of that, we'll find that those two angles must be the same, so angle 2 also has to be 38 degrees. Our final theorem of the day says that the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So you can see sometimes it's inside the circle, sometimes it's the larger part of the circle. But in this case, that angle with the tangent and the chord is still the half of the intercepted arc. So let's take a look at our final example. In the diagram, we have segment KJ, which is tangent to the circle at J, and we're asked to determine the values of both X and Y. Now, one of the things that I'm going to look at is this inscribed angle, since that's one of the only things that I have in this is that 35 degree angle. Now, since that has a 35 degree angle measure, and we know that by going from the arc to the inscribed angle, we take half of it, here we're going the opposite direction. So this arc is actually going to be double 35, or 70 degrees. Now, as I work my way around the figure, we have chord JL and tangent line JK. That's that angle measure at X. So in this case, we know that that's a chord and a tangent line, and they must be half of the intercepted arc. So X is going to actually be 35 in this case, the same as the inscribed angle. Now, I want to continue to look at this picture in as many ways as possible. So I'm going to go back to one of the corollaries, and I'm going to say since QL is a diameter of this circle, angle QJL must be a right angle. Now I'm going to go back a few chapters, and I'm going to see this triangle on the inside of the circle. And I know that I have a 90-degree angle, so there's 90 degrees remaining. And if I take 35 from that, I know that y has to be 55 degrees. So we've gone over several examples in section 12.3, all about inscribed angles. And the important thing to remember here is that an inscribed angle is half the measure of its intercepted arc. Thank you very much for your time, and I'll see you soon.